Two situations in which we might use percent equation are finding interest and depreciation. Interest is an example of when money appreciates or value appreciates or increases. And depreciation is when value decreases. Ideally, we try to maximize the opportunities for appreciation of money and minimize our opportunities where the money is going to depreciate. Here's an example of when money grows or appreciates. Money in a particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is $100, $50, $200, $125, or X dollars? So we're going to use what we know about the percent equation, which says that the part is equal to the percent times the whole. Now in this case, the percent's going to be the same every time. We want to find the value after a 6% increase. So we're just not adding, we're just not finding 6%. We're actually finding the original amount plus the 6%, which means we're finding 106% of the original amount. So for each of these instances, we're going to use 106% as our percentage, but of course we want to convert that to a decimal before we do that. I can move it to move the places 2 times to the left to find my decimal equivalent. So I'm going to be multiplying each of these values times 1.06. Now, you can certainly use your calculator to multiply 1.06 times 100 to find your answer. I would challenge you to attempt some mental math ways to solve this. I know that 1 times 100 is equal to 100. And I know 6/10 of 100 is equal to, well, 6 out of 100, 6 hundredths. 6 out of 100 is simply going to be 6. So this is going to give me 100 plus 6, which is going to equal 106. Another way I knew that is that if I multiply anything times 100, it's going to move the decimal 2 places to the right, which would also give me 106. So now 106 or 1.06 times 50, well, if we know 1 whole times 50 equals 50, of course, 6/10 or 6/100 rather of 50. Well, I knew 6/100 of 100 is 6. Since 50 is half of 100, it would reason that 6% rather of 50 is going to be 3. So this is going to be $53 after a year. 106% of $200. Once again, if I know that 6% of 100 is $6, then it reasons that 6% of 200 would be twice that, $12. So 100% of 200 is 200, 6% of 200 is $12, for a total of $212. This one's not quite as obvious, but if I need to find out 106% of 125, I'm going to look back to 50 here. I knew 6% of 50 was 3, so 25 is half of 50, so that means half of 3 will be 150. So if I add that 150 to the interest on $100, which was $6, that would give me a total of $750. Again, that one might not be as obvious as some of these other ones. So 100% of 125 is 125. 6% of 125 is going to be 6 plus $1.50. 6 because that's 6% of 100, and $1.50 because that's half of $3, which was 6% of 50, for a total of 125 plus 750, or 132.50. Now finally, what's the algebraic equation we can use each time to find the value after interest has been added. Well, we're doing the same thing every time, so a reason that our equation would simply be 1.06 times x. So now another example of when we might use the percent equation